Hey, hello, folks. Welcome back to another live stream. And this time we have a very big hackathon for you folks. So this week we are hosting a hackathon with $10,000 in prizes, and the name of the hackathon is the Hangover Hackathon. And the sponsor of the hackathon is Cognee. So you can, just head over to www.vmedevs.org/hackathon/Cognee, and you can find all the details of the hackathon. As you can see on the screen, you'll just be landed on this particular page. Um, you can find all the, pricings, all the tracks on which you can take part. Also, you'll find all the information in and around Cognee. Uh, just don't forget to start the repo. The product is really cool, so you might want to give it a try. And if you are new, you can, and if you haven't already registered, make sure to register before start building the project. And so all the information of the hackathon is there in this particular page. Make sure to check it out. And if you are someone who has already participated, and if you are feeling stuck, make sure to join Discord, and you can join it from resources tab. So you can join Cognate Discord, and you can maybe ask all the questions you have regarding the hackathon, and the team is there, and it will be there for a complete week to answer all your queries regarding the hackathon. One important information for folks who have already participated and are aiming for the Cognee Cloud track. So we'll make the Cognee Cloud active for you folks on Wednesday. Until then, you will be on the wait list. Just bear with us till Wednesday, and then after that, you can start building with Cognee Cloud as well. Until then, you can get yourself prepared and get all the things which are required before hitting the Cognee Cloud ready, and then after it comes live to you, you can just start making a project. I guess that's it. And I have Cognee folks with us. Dave, Voss, would you like to give yourself a quick introduction? Maybe we can start with Voss.
Sorry, you want to start with me or Voss?
Let's start with Voss.
Hi, nice to meet you all. I'm Vass. I'm founder of Cognee. I've been building in the data space for around 10 years, and then decided to start Cognee as I was studying cognitive sciences and got an idea of building a memory layer for AI apps and agents. I've been building in this space for 3+ years. Cognee started as an idea, and I posted it on socials, and now it's a company of 17 people building between Berlin and San Francisco. I'm here in San Francisco right now, and I'm happy that you guys are joining us and participating in this exercise. We have more than 200 pull requests, hundreds of issues open, and I'm really looking forward to see what you guys can build. We gave you some really tough tasks. We gave you some really easy ones. So I hope we see that you guys are able to kind of juggle these and come up on top and win. In just in case terms, issues are going to be shown on Cognee's repo. They're going to be labeled with a hackathon label. And what you guys can do is effectively comment and build a proposal on how you want to solve the issue. The best proposal wins. You start working on this issue with your team, and then we would basically merge the best one. There is some big rewards. There is interviews with Cognee team for a potential role in Cognee in case of really good applicants and people solving the really hard tasks. And we hope that we see one of you working with us closely over the next period and becoming a core member of our team. Thank you again for participating. I'm handing it over to Dave, our founding DevRel, who's going to share a bit more about Cognee and about this hackathon.
Great. Hey, thanks a lot. Let's see, make sure I got my screen here showing. Okay. Yep. Yeah, my name's Dave Nielsen. All right, thanks. Yeah, my name's Dave Nielsen, and fairly new to Cognee, but I'm very excited about this hackathon and learning more about all the different opportunities there are to contribute. We've put up, let's see if I switch my screen right here, you can actually see. Hold on a second here. Oops. See. We've got 184 issues in the repo right now, in the Cognee repo. So if you were to go there, you can search through 184 issues. Some of them are, most of them are still open. There's quite a few that haven't been assigned yet, so you've got lots of opportunities to find one. If you've got one that you are interested in submitting to, or actually I should say, if there's an issue that you'd like to create, let us know in the Discord channel. But there's just a lot here to find. So what is it that you're going to be doing? Well, first of all, I'm just going to show you real quick. Cognee has a very interesting interface for both its cloud and its desktop, or its open source version. There's a lot of really interesting information that you can get out of submitting or contributing, sending your data to Cognee. And not only do you get this really interesting, what we call a mind map, which shows you the relationships between the data that you send, but we also do a lot of work to get it there. And so, what's really interesting about the reason why you're contributing to this or participating in this hackathon is that this is cutting edge. This is very much Cognee showing the way towards where memory is going, and you can be a part of that. So when you send your data, when the data is sent to Cognee, it goes through a pipeline, and it extracts a lot of knowledge out of this on its own. So without you having to tell it anything, really. And so you just send your data, and we do the work. Now, there's a lot that goes on behind the scenes, and so we're not going to get into all that right now. But the opportunity here is to help us make this whole process better, easier, provide your feedback. You can contribute to the open source code, you can contribute to integrations, you can contribute to sample applications. There's just a lot you can contribute to. But what I'm showing you right now is the cloud interface. Let me switch my screen over here a little bit. And then beyond that, we also have the open source interface. So you can set this up on your laptop, you can run it on your laptop, you can send the data to your laptop, so everything runs on your laptop. You can send it to the cloud. I think you'll get the most out of installing it on your laptop, so you can actually try out the open source. It's all free. You don't have to worry about paying any money. If you want, you can actually even run an LLM on your laptop if you've got enough power. Otherwise, you'll need a key for that. But the options, the power is here. And so what I want to do real quick is just show you very quickly what happens when you what the process is for installing it. I'm not going to go through the whole process because it takes a little while, but let me get back over here to the repo. There we go. Okay. So most of you already know this, but if you don't, then you can go to the GitHub repo, which the original name of the company was Topateretes. I'm probably saying that wrong. But the GitHub repo is Cognee, and that's the company name now. And you just scroll down the page. Obviously, that tells you, why use Cognee. It gives you some information about how it works, and then you get to the quick start. So there's a couple prerequisites. It's not that much. Just Python 3.10 to 3.14, and it shows you how to install it. You can install it with pip install. There's a couple different other options. If you have an older laptop, like my laptop, actually, my primary laptop screen cracked, so I'm actually running right now on a 10-year-old laptop, and I was able to install it. But for me, what worked is to install it using Cloud Code, because I ran into some challenges with older libraries and stuff like that. But I was able to actually have Cloud Code fix those for me and get everything running, as you can see. Right here. This is actually running on my laptop. So, but you choose your path. Sorry, here we go. You choose your path, and just make sure that you get your LLM API key. That's needed in order for Cognee to process the data and categorize it. And then make sure you set up your environmental variables with your keys. And then here's a run the pipeline sample app that you can use. And this is going to do some very basic commands here. And for those of you, again, who are new, basically what you do is you want to send data to us. You can send it as a file, or you can send it as a string of text. And you use the word remember, okay, the command remember. And what this is going to do is just going to send it to our servers, and then we're going to take it from there. Okay, and you can send as much as you'd like. You can kind of think of it like, I kind of joke, my daughter once was talking with her friend, and her friend was, this is a while ago when she was in middle school, elementary school, and they were talking about like what is an essay, and they were talking about how it's a series of like social media posts. So, you can kind of think about submitting text to us, but you can also submit documents. So it doesn't have to be one or the other. And yeah, and then when you want to recall that data, you can ask it questions. So once the data is processed in Cognee, it's now then made available in a knowledge graph, and then you can ask it questions. And so it will be able to pull those answers out for you. And then the way this is really useful, in my opinion, is not only just to ask it questions, but in the middle of any sort of when your users are prompting, like if you're providing a prompt interface for your users, and you've already had a conversation with them or with their peers in the company, and you don't want to have to keep asking the same questions over and over again, you can send the data to Cognee, and then when they ask similar questions, you can get the context from your knowledge base from Cognee and send it along with the question to the LLM, and then you're providing all that context, so it's not forgetting that they've already had this conversation. So that's just one way in which you can use it. But with that, I'd like to turn it over to Vas, because I'm sure he has some additional suggestions and use cases for us and some other input. So Vas, why don't you take it from here?
Yeah, sure. So maybe just to add a bit towards this, I'm going to share my screen. And you can see here the issues, right? Effectively, what we get here is all of the potential things you guys can work on. And for example, this integration task is switching dataset miss session, how to actually do it for our integrations. And what you can do is you can effectively open this issue, start commenting, looking at the details of the issue and how you could actually go and solve it. Now, the pull requests that are already open, until the issue is assigned, we won't really take these PRs too much into consideration for those who just pick up the issue without getting it assigned to them. So you need to first get the issue assigned, then only after that will the issue be taken and taken into consideration. So please don't work on issues that haven't been assigned to you, because we won't take those into consideration for the launch. Some of you have been quite busy. We have more than 200 requests from around 20 a couple of days ago, and we'll take a bit of time to review all of them. But down the line, we would encourage you also to be quite careful around this. Now, in terms of how Cognee works, I think Dave explained a bit about getting started, but there is also a couple of other things you guys can check. First of all, what you can do is you can use Cognee CLI. So Cognee CLI is a command line interface that allows you to interact with Cognee on your terminal, or ask Cloud Code Codex, OpenClaw, and Rust clients to set Cognee up for you. So there is not only one repo here, you have other repos that are going to be either in integration or they're going to be completely dedicated repos by themselves. So for example, Cloud Code plugin is something that you can open up, set up on your Cloud Code, get memory for it, but also work on tickets related to it. So Cognee is not just one Python tool. It contains an integrations folder. Integration folder has connections to all other integrations and agentic frameworks, and you can test these depending on which one you use. Not only that, Cognee has an ability to be run as a Rust client, as a TypeScript client. So if you want to try Cognee as a TypeScript client, you can download it from NPM. It was just released this Friday. You can try it. You can open other issues. We'll also assign those based on the priority and relevance. And then finally, what is definitely something of interest for those of you digging deeper is that Cognee is consistent of many building blocks. So the building blocks of Cognee are effectively called data points. Data points are atomic units of knowledge that are abstraction of a pedantic data class. So in our documentation, you can find a data point, a definition here, together with an example. So let's kind of have a look at that. Data point would be something like this. it would contain some information, but where it really starts shining is you can effectively take any type of an object you have, a person, a dog, a cat, a house, and you can start connecting them. So here we have a person we define with a name, age, and some metadata. And then what we can do is we can define a book, and then we can connect the book to the author, for example, with an edge. So all of this is effectively allowing us to connect the dots, bridge the elements inside of these data points, and create relationships where we can effectively, for example, have an author connected to a chapter here, and have maybe author connected to a publishing house. So all of these types of relationships are what builds the memory, and we can build many types of representations with your own data. And what Dave showed you was a high-level API for doing that, but you can really granularly control it. And as you're building different types of implementation patterns, you can look at the data points. Data points are being processed by tasks. Tasks are Python functions that effectively look something like this. You have some executable, you have a task wrapping it, you have some config you can pass, for example, the chunks, the information around them. And then you can tie in these tasks one after another to get a pipeline. So a pipeline is a representation that effectively is running a group of tasks. So you can see that for a pipeline, we can run a group of tasks for a certain data set, for some text. Data set is a group of files that are sitting together in some folder. And then you can effectively get the maximum out of Cognee and build your own custom memory if you need it. What you've seen so far is just the default version, but then if you build your own pipeline, if you build your own ingestion, you can use just Pythonic data pipelines to persist and store the data in the graph and vector stores without really needing to know a lot about the embeddings, a lot about the graph science. You can just connect all of the dots with Python. If you are confused or unsure how this exactly works, I would say you can definitely use coding tools. But down the line, if you really want to do the hard tasks, I would encourage you to really think things through and to really build the right set of tests that would represent the ideal way that your code is going to behave in production. The coding tools are still not there yet to build a very complex representation. So if you just throw some code, some LLM at it and iterate, it's not going to get there. It's going to be not working. It's going to have too many edge cases. So sit down, think about what is the representation and the problem you're trying to answer, build the tests around it, use the coding tools to help you iterate faster. But down the line, you probably need to also check it manually. And when you do that, and when you open a PR, we will have a look. But in the case you send us some type of LLM-generated code that doesn't really compile and work, we won't consider those submissions. We are expecting that you work with us and really making sure that what we merge to production that ends up in 100+ companies that are using Cognee is reliable, is trustworthy, is something we can really sit down and work with and give it to our users and make sure that it reaches production in 100 companies globally, worldwide. So that's just a couple of things on how internals of Cognee work, and a few more details on how Cognee operates. So Cognee has Cognee.remember function. Cognee.remember function that Dave showed you contains two major pieces, two major pipelines that I just explained. One pipeline processes the data and creates a memory layer, but the second pipeline improves it. Self-improvement of the memory layer means that we connect the dots in a new way. We put some weights on certain elements of the memory. We play around with things that allow us to dynamically shift the memory based on how we interact with it, but also similar to how humans do it. So what I would encourage you to do is really dig into the source code, try to understand how these pipelines work. We have all of that also covered in the documentation. In case you have difficulties or are curious about how to approach it or where to go with it, let us know. We're more than happy to answer questions on Discord. But I would really encourage you to spend some time understanding, because this is a relatively new area and the way we process the data is quite novel. So if you just try to solve it with the traditional methods, you might end up in trouble. So yeah, that's as much as I wanted to share in terms of like a bit deeper insight of Cognee. Just maybe a few more things on how Cognee can be connected to your apps. We have an MCP server. We have the integrations with OpenClaw, Cloud Code, Hermes, and Codex. We also have the TypeScript Rust packages, and we have Docker images together with the images on the Docker Hub on the Docker repository. So what I would say is, hey, try using all of those entry points or one you like. If you have some issues or difficulties, one of them, let us know. We also made some tickets to build more automated tests around them, so we make them more reliable in the future. But so far, they have been used proactively by many organizations. So that's all from my side for now. Dave, passing it back to you.
Great, thanks. Yeah, one last thing I want to, by the way, great detail, thanks. One last thing I want to show you is one way in which you can just get easily started is, oh, here we go. Okay, so when you go log into the cloud, you will see this welcome page. There's a get started button. If for some reason you get lost, the URL is platform.cognee.ai/onboarding. It will take you here. And then when you click on that button, it gives you 3 different ways to get started. Basically to connect your agent either through Cloud Code, Codex, or you can upload data directly into Cognee. Now, I just want to show you this because this is a very easy way for you to understand how you can get started. So let's just pick Cloud Code here and click on Connect Agent. And it's just going to give you exactly what you need. It will already have here for you to copy the variables that you need to set, or one way to set the variables is to export them into your environment. And so you can click copy there and then just go to your terminal and paste it. Then you go to the next step. And this is once you have Cloud Code installed, you go into Cloud Code and you copy and paste each one of these strings, basically commands, into Cloud Code. And it will go ahead and it will add the Cognee plugin in from the marketplace, and it will actually go and install it. And then you just have to make sure that you click the reload, you do the reload as well. And then from there, you're all set and you'll be able to start working with Cognee. So this is the easiest way to get started if you are using Cloud Code. Again, if you're using Codex, we also have the steps there for you as well. And I would highly recommend that you try this out, because this is one of the use cases, is that once you start to use it with your own code environment, it's going to be tracking that agent conversation. So the conversation you're having with that agent will be tracked, and you can then recall. And some of the ways in which people are using Cognee is for teams, across teams that are using agents. Then it is capturing the conversations you're having with the agents, and then sharing that knowledge with your other teams. So that's one use case. And so now you can get to install Cognee yourself and then also experience that use case. So this is one way to get started. But all right, so with that, what do we want to do? Do we want to open it up for some questions?
Yep. Let's take a few questions from the chat, because I see there are quite a few questions. So I'll start, just give me a moment, boss and Dave. I'll just start with the operational question and then I'll give it to you folks. Folks, I'll appreciate if we can keep questions more relevant to Cognee here, because again, we have Dave and Voss, and you can ask anything in and around Cognee and they'll be able to answer you well. As far as this question is concerned, so you can submit 2 different projects in 2 different tracks. One project in 2 different tracks is not what we would want. And for any hackathon related question, you can join Discord, and even I am there answering questions about all the hackathon operations. So just join Discord, ask your questions there. And for this live stream, let's keep it specific to Cognee. And if you are finding trouble in joining Discord, every information around the hackathon can be found in the link in the description. So just go to the link and you can find all the relevant information. Yep. There's this question by Akshat. If you want to take it. I'll just read it out loud for you folks. If an AI agent gives a wrong answer using Cognee memory, how can we debug where the mistake came from? Can we track it back to the original document or graph connection or a retrieved context?
Yes, of course. So in the search, you have an option to enable the feedback, so to enable the reference point, and then the reference point is going to go all the way back from where the answer was generated from and give you the actual source of the information. So you can definitely do that, and there is a flag in the search that you can enable.
Sure. To run Cognee on Windows, is there any constraint or do it need a specific RAM laptop?
I'm not aware of any constraints. I think 8 gigs of RAM should be enough. We test Windows, but we do not optimize for Windows, considering that most of our users use Mac or for Linux systems. But I'm pretty sure it works.
Yep. To all the folks who have missed the detail in the starting, so you'll be able to log in after Wednesday. Until then, Cognee Cloud for you folks will be on waitlist. So just bear with us till Wednesday, and after that, you can start building or maybe deploying our project or using Cognee Cloud. Until then, what you can do is you can either explore GitHub issues on Cognee Cloud, and we have already seen that Voss and Dev has shared how many issues they have opened on Cognee open source repository, and or you can just maybe try Cognee open source and maybe try to self-host things. Also, there is one more issue, one more thing I wanted to highlight. If you are taking part in the PR section, make sure not to generate AI code and submit PRs. Make sure the code which you submit as a PR is high quality code, and the limit of 5 PRs is that you can only be assigned to 5 issues, and you can only submit 5 PRs per participant, and any more PR by that participant will not be encouraged. So make sure you only submit 5 PRs. I did not get this question, folks. If this is anywhere relevant to Cognee.
I don't think that the choice of your MacBook is relevant to Cognee, but definitely we encourage having as good machine as you can afford.
Yeah. So there is this question about Cognee. How does Cognee prevent irrelevant but semantically similar info from being retrieved? This is a common yet big issue in RAG systems where the retrieved context looks related but is not actually useful.
So with Cognee, you have ability to retrieve the data by using global context tree, which is enabling connections between different data points in the system and creating a structured representation or a meta representation that reasons through the different, let's say, ways you were interacting with the data in the past and finds the right representation there. We also add weights and self-improvement to the memory, so we can always prioritize what's more relevant. You can check that in our documentation under the self-improvement section.
If you're building a memory-first AI agent, what's your recommended architecture and what is stored in Cognee, the app database and the LLM?
Cognee can be used just with Postgres. So we store there the session memory of the agent, we store there the permanent memory of the agent, and we effectively store the graph and vector stores all in Postgres. That's the simplest way you can go. Initially, Cognee comes with configured file databases, LansDB and Kuzu, which is now called also Ladybug. And these are files as databases, don't ask you to build any type of a server. If your agents have multiple threads or are trying to contact that database at the same time, it will lock. So it's best to set up a fast API server using Postgres, and that's the recommended way for it to just move forward.
Sure. If you're building a memory-first AI agent, what's your recommend? I think this is the one we took right now, right? Oh, I think this was the program. I'm really sorry. What's the recommended chunk size of Cognee? We are getting close to 19K tokens from 15 retrieved triplets.
Depends on your use case, depends on how you implement it. I think the default chunk size is 4096, if I'm not mistaken. It we or 4000, yeah, something like that. Or yeah, that should be it. So I would say you can start with that. You can configure it. You can add your own chunkers. The chunkers are on track class in Cognee, so you can iterate on them based on the data you're ingesting. We are not too opinionated on
that. I guess we can wrap up here, folks, because I see there are a lot of questions. And folks, if you have still questions left, you can just head over to Discord, and the team will try to answer all the questions there. And Vas, Dave, do you have any like closing remarks for the folks who are there in the hackathon? How should they build the projects in order to get highlighted or maybe win big?
Yeah, I mean, take this as a learning experience, both for you, yourselves, and us. The cloud will be available on Wednesday. In the meantime, please focus on the SDK. We had a hug of death in terms of traffic. There were so many of you that tried to use the cloud that we had to postpone a bit the entry until we could get things ready, and I apologize for that. But down the line, I think the SDK that you see is you're also able to run it. You can run it with the Llama locally. You can already avoid kind of spending the money by just using what's there in the open source and building together with us. And we are really looking forward to seeing your feedback, learning from you, and also helping you learn about memory. And yeah, don't hesitate to reach out on Discord. We have 2 people assigned half days just to work with you guys over the next period. And we have a whole, and an engineering manager is also managing all the inbound tickets and assigning things to you. So we are there for you. Ask us things, and Dave is also going to be there to support the team. And I'm going to also be jumping in from time to time if I can help with that.
Yep.
Yeah, and by the way, is there a way to follow up the questions here? Because there are quite a few. Is there a way to like reach out and contact these people to give them the answers?
If you want, like, if you have time, maybe we can take questions if you feel we should be taking the ones, or what we can do is we can just ask them to post in the Discord, and then you can maybe follow up.
Okay, well, yeah. For those of you, there's a lot of questions here. A lot of subtle questions that maybe not everyone is interested in hearing. So please take it into the Discord. There is a hackathon specific set of channels, so you can go into those and ask the questions there. There's also a general channel if you have like just questions about Cognee in general, so you can ask questions in the general channel.
Yep.
And one last thing I'll share with you is that one way to get a better chance of getting your issue, getting accepted to solve an issue, is when you comment on the issue. That's how you let us know that you're interested in the that hackathon issue. Provide some suggestions about how you would go about solving the problem or addressing the issue, and that. Because we go on first come, first serve, but if nobody has said anything and you provide like an actual thoughtful answer about how you'd address it, we will choose you over the people above you if they haven't said anything. So yeah, that tip should help you. And one last thing, there's another question here was can you solve your own issue? Can you like do your work on your own thing? Yes, absolutely. What I recommend you do is reach out to us through Discord. And let us know that you have an issue. We can create one for you and make sure that you have something to work on. We'd be happy to do that. And
Yep.
That's all I've got for today.
Yep. Thank you, Vas. Thank you, Dave. And thank you, folks, for taking part in the hackathon. You have complete week to build something good and, build something around AI memory. If you are still stuck, just check the link in the description. You'll find all the relevant details. You'll just head over to hackathon page. You can join Discord from there. You can find all the relevant details from there. Yep. Thank you for joining, and we'll wrap it up here. Bye.
Bye, everyone. See you online.